Okay, so now we're ready for some freaky things to start to happen. So I got a lot of stuff going on in this problem. I have that inverted cone, which I drew. They told me the height was 6 and the diameter was 4. So, ooh, they're trying to be tricky. So I have to change that to a radius of 2. They tell me that the water is leaking out. So I know I have a volume. Now, here's something that they're trying to trick me. This is in centimeters. And over here I have height and radius in meters. So I'm going to need to change those meters into centimeters. And so if I do that, then of course I'd have 20 and 60. Oh, excuse me. Let's try 200. 200 and 600. But it doesn't matter. It's still going to reduce to 2/6. And then I can solve for radius because, again, if I'm looking at the water level rising, then I'm talking about that height potentially changing. So I'd like to get it in terms of a single variable. So the water level is rising at 20 centimeters, so there's my change in height. That's in centimeters, so that's good. I don't have to make any changes. And find it when the height of the water is 2 meters. Oh, they're trying to trick me again. That's meters, so I have to change it to centimeters. Okay, so I've written several things down. Pause the video long enough to make sure you know where I got everything. Working on my formula over here, and I substituted in for r. So I'm going to have a grand total when I'm all done squaring of 1/27 pi times h cubed. And then when I take the derivative of it, my derivative will be, when I finish powering down, 1/9 pi h squared dh dt. So now I'm ready to start plugging things in. And I find it a little bit interesting that I actually know all these values. Like, I know h is the 200 centimeters. That's going to be large when I square it. And I know dh dt. So this means I can figure out the volume for my cone, and I get this crazy large number. So now the question is, what the heck was I supposed to find again? Well, here's what I have to remember. Two things are happening simultaneously. I have water leaking out at the same time water is being pumped in. So right now, this is my total change in volume. But if I think about that, the volume would actually equal the amount being pumped in minus the stuff that's being pumped out. So I know the change in the total. I have to figure out what's the change in the amount in, what's the change in the amount out. Now, the change in the amount in, well, it says it's being pumped in at a constant rate, but I don't know what that constant rate is, but I do know that it's leaking out at 10,000 centimeters cubed per minute. So the amount in, I'm trying to figure out. I have the total change, that's what I just substituted in, and I know the amount leaking out. So now I just need to add 10,000 to the other side. I'm not even going to get a common denominator, I'm just going to write it that way. So there's my final answer. I just added the 10,000 over, and that tells me the rate at which water is being pumped in. If I put, of course, that fraction in my calculator and add 10,000, then I get, a little tiny number. Looks like this. And it would be centimeters cubed per minute.